Calculus BC, we are looking at lesson 3.3, and this is really jumping into the shortcuts, something that, thank goodness, we've already been making use of. Real quickly, if f of x equals y equals mx plus b, in other words, if you have the equation of a line, f prime of x would just be m. And for any line, what that's really saying is the tangent line slope. If you were to draw a tangent line, you'd be drawing the same line, wouldn't you? If you drew for a tangent line drawn to that line at any given point. Of course, our shortcut would make sense. What if y equaled a number like b? That would just be a horizontal line. F prime of x would equal 0. The shortcut is saying that the derivative of a number would be 0. The power rule, wow, super important. F of x equals x to the n. F prime would be n times x to the n minus 1. What does it mean? X to the fifth, the derivative is 5. X to the fourth, 4x to the eighth. Drop down the 8. 8 times 4 is 32. Decrease your power by 1. This becomes x to the negative third, so you'd get negative 3x, and now you subtract 1, you'll get negative 4. You could also write that as negative 3 over x to the fourth. The cube root of x is where we're going next, but look, if you have a fractional exponent, same thing is going to hold true. Drop that power down, and then subtract 1 from that power. So we have x to the 1/3. We'd say this is 1/3 x to the. When you subtract a 1, you'd be at negative 2/3. Here we'd have x to the 3/2, wouldn't we? So we'd drop down a 3 over 2, and subtracting 1 from 3 over 2 would leave you with 1/2. This really is x to the negative 1/5, I hope you're familiar with. So you'd get negative 1/5 x to the, well, when you subtract a 1, you'd get negative 6/5. Nice shorter lesson today. I hope as you're looking at this, this is making sense to you, that you've seen this a lot. The product rule. My goodness, if you have two functions multiplied together, if you're going to take the derivative of them, it's the first function multiplied to the derivative of the second plus the derivative of the first function multiplied to the second. Very often, by the way, I'm going to show another way to write a derivative, capital D sub x. That's saying take the derivative of a whatever you have with respect to x. Let's say that you have two functions, u and v. That would be u v prime plus u prime v. So what we're asked to do here is essentially take our derivative. Here is our u, here is our v. So we're going to say, well, we've got our u. That's right here. Then we need v prime. Well, the derivative of x to the fourth is 4x to the third minus a 1. Then we need to do a u prime. Well, that's going to be a 2/3 x to the negative 1/3, isn't it? And then we're going to multiply that to v, which is x to the fourth minus x plus 2. Guys, tell you what, you should see if you can combine like terms and simplify. I'm going to right now distribute. We're going to add powers together. 2/3 plus 3. Well, if you did 2/3 plus 3, 3 is really 9/3, isn't it? This would be x to the 11/3. Then we'd see a minus x to the 2/3. I'm going to distribute over here just as well. We've got to do some more work here. Here's a 2/3. If I had negative 1/3 plus 4, that's really like negative 1/3 plus a 12/3, isn't it? So here we get x to the 11/3. We'll say minus, we'll say here's our 2/3. What's negative 1/3 plus 1? Well, that's going to be a 2/3, isn't it? And then finally, 2/3 times 2, you'd get 4/3. You'd have x to the negative 1/3. Well, we just have to combine our like terms together. We'll say here's our y prime. 2/3 and 4. Well, again, 4 would be 12/3 plus 2/3 would be 14/3, right? And that's 14/3 x to the 11/3. And then here we have a -1 and a -2/3. That's going to become a -5/3. And then finally we could say plus 4/3 x to the negative 1/3. So that works out nice and quickly. Product rule definitely gets used extensively. The quotient rule, when you're dividing two functions, that's something you need to memorize. And guys, you definitely need to do more work here too. Here's how the quotient rule works. It's the lower function, v, times the derivative of the upper function, that's u prime, minus the upper function, u, times the derivative of the lower function, that's v prime, all over v squared. And there's a little saying that can help you memorize this. You'll hear people say low d high minus high d low all over low squared. And, that more or less is what you're seeing right here. When you say low function, that's v. D high, that's the derivative of the upper one, that's u prime. Minus the high function, that's u, times d low, the derivative of the low, all over low squared. So you'll hear a lot of teachers and professors say, oh, quotient rule is low d high minus high d low all over low squared. Well, let's go ahead and see if we could work out this example at the bottom. This derivative would be the low function. Here's x squared plus 1. We'll say derivative of the top. What's the derivative of x squared minus 1? Well, guys, that's 2x. Minus the upper function. That's x squared minus 1. How about the lower function down there? Well, that's going to be a 2x. And then down below we'll have our low function squared. Now, guys, I do want to point out that you don't have to do what I'm about to do here, but the method I'm about to show you will be super helpful for other problems. In fact, it's super important, even though this is an easier problem. We're not done. We want to simplify. Look at the top with me just for a moment. That top has something in common in the numerator. Both parts of the numerator have a 2x in there. I'm going to factor that 2x out. Now again, whether you do that or not, you're going to get the same answer. But so very often, this is going to really help you out. Look at this. When you distribute that negative, you get a negative x squared plus a 1. This x squared and the minus x squared cancel. 1 plus 1 is a 2. By the way, I think kids might say, oh my gosh, you don't even need to write that 2 out. Just multiply it together. Of course. You get 4x all over x squared plus 1. Whole thing squared. Again, I guess what I really want to encourage you to do is, just hone up those algebra skills so that you can break these derivatives down. It's been said that calculus is ultimately 80% algebra. What that means is once you perform some basic derivative rules, or as we get into more advanced integration properties, we'll even talk about what that means later. So very often, then the problem just becomes algebra. And honing up those algebra skills is super, super, super important. So you can see how factoring can really come in and make a big, big deal, and it can make life easier. Let's do this very last problem here. And I'll be honest with you, this one in particular is going to be a little bit tougher with the simplifying. Again, let's remember what the quotient rule was all about. It was low d high minus high d low all over low squared. So here's your high, here's your low. So I'm going to say here's my low, it's 2x to the 1/3 plus 1. D high, well, what's your d high? The derivative of 3x minus 1 is just a 3. Minus, well, now we've got our high function, 3x minus 1. Herein lies the problem, and I think you can see why this problem is going to get a little bit tougher. The derivative down below here is going to be bring your 1/3 over, you get 2/3, and then this becomes x to the negative 2/3, right? Derivative of 1 is just 0. And down below then we'll have a 2x to the 1/3 plus 1 whole thing squared. Now guys, at this point, I just want to state the obvious. What the real problem is, without a doubt, and I think if anybody were to look at it, even in a couple of seconds, they'd realize this is a very unpleasant reality that we have a complex fraction. We have fractions inside of fractions. Now, just because we've got some space here, I'm going to rewrite this just ever so slightly to just drive something home. Like I said, so much of calculus is actually going to be algebraic manipulation here. And I think right now you can see, oh my gosh, how in the world do I deal with this yucky fraction within a fraction, that 3 all over x to the 2/3? The quick answer is, guys, you actually want to multiply the top and the bottom by that pesky little denominator that's causing all the trouble. Okay? So you're going to distribute that everywhere. As some teachers have said, they'll say multiply each part of the problem by 3x to the 2/3. Now, in so doing, what you're really doing is you're multiplying by 1. You can see what I have right here. Whenever you multiply the same quantity over itself, you're multiplying by 1 and you're not changing your problem. But look, as I multiply this 3x to the 2/3, I'm going to just focus in over at the 3 right here, right? And 3 times 3 becomes a 9, and then we'd get x to the 2/3. And then I'll distribute from there. This second part of the numerator is actually easier, guys. I think you can see that the denominator in question just canceled. I'm even going to slide that 2 out in front there. And then down below we'll have our 3x to the 2/3. I'll move that out in front. Guys, I hope you're seeing right now that, yeah, the problem, got messy, but it looks so much better. I'll tell you why. You no longer have those pesky fractions within fractions. So let's just do a little cleaning up. I'm going to distribute that 9x to the 2/3 to both. 9 times 2 is 18. And what's x to the 1/3 times x to the 2/3? Well, add those powers together, you just have an x. And then you could see here's a plus 9x to the 2/3. Now I'm going to distribute this minus 2. I'll get a minus 6x plus a 2. Guys, we are so close to wrapping up. can see things are getting better by the moment. As I'm just looking here, I'm seeing two like terms, 18x minus 3x, that's a 12x. And down below we've got this. So one word of caution though. One word of caution as we're finishing. Please remember your basic algebra. This right here is your answer. Sometimes what kids mistakenly do is they will say, oh, would you look at this? Here's an x to the 2/3 and an x to the 2/3. I'm going to cancel those out. Guys, you can't because of those additions up there. As soon as you're adding something, you really have an understood set of parentheses around there. And, that's like the order of operations. You can't just cancel those x to the 2/3 out. I know it can be tempting, but I just wanted to point that out to you because it is a common mistake that kids can get into as we begin going over some work with calculus. So having a little bit of trouble there, just erasing that highlighting. But hopefully this helps you out. Try to reduce as much as you can. Best of luck to you.